Welcome to Intro to and/or Probability. So before we go over and probability and or probability, we're going to cover the basics of, basic probability first. So let's say we flip a fair coin. That means you have an even chance of getting heads and tails. The possible outcomes for the fair coin is you either get heads or you get tails. You're going to put this inside of brackets. That way, we know it's both of your possible options. When you put it inside of brackets, this is actually called your sample space. So your sample space is just the set of every possible outcome that can happen. For part B, what is the probability of getting tails on a single coin flip? Well, you have 1 out of 2 chances, right? You can either get heads or tails. That's your 2 options. Only one of them is tails. You can write this also as 50%. Or you can express probability as a decimal. For the sake of this unit, we're mainly going to be expressing probability as fractions. So let's say we roll a fair 6-sided die, and they want to know what are the possible outcomes. In other words, your sample space. You have 1, 2, 3, 4, 5, and a die goes up to 6. Because it's your sample space, you're going to put it in squiggly brackets. Now, the probability of rolling a 5 is there is 1 5 out of the 6 different outcomes in your sample space. The probability of not rolling a 5, well, you have 1, 2, 3, 4, and the 6. So that is 5 options, that's not a 5, out of your 6 total. These are actually called complements. And we know they're complements because they add up to a total of 1. So a complement is when you have the probability of something happening and the probability of something not happening, right? If there's a 1/6 probability that it's going to happen, there's a 5 out of 6 chance that it's not going to happen. Together, they make up a total of 6 out of 6 outcomes, or 100% of your outcomes. So the probability of rolling a number, double number, the probability of rolling a negative number is 0, right? Because there are no negatives on the die, so you have 0 out of 6. Or you can see that just as 0, or 0%. The probability of rolling a number less than 10. Well, your sample space is 1, 2, 3, 4, 5, 6. All of those are less than 10, so you have a 6 out of 6 shot. Or you can write that as 100%. Or you can write that as just 1. So keep in mind, if you see a probability of 1, it means 100%. It will always happen. A probability of 0 means it will never happen. Also keep in mind, for all of your answers, all your probabilities should be between 0 and 1. 0 for not happening at all, 1 for always happening. If you ever get an answer of a probability greater than 1, you made a mistake. You can say you gave 120% effort, but in reality, that's not true. You either gave it all of your effort or nothing. Like, you can't give more than 100% when it comes to probability. So let's go over some key terms and definitions. The first one is probability. So it's the chance or likelihood an outcome will occur. It's usually represented as a fraction, decimal, or percent most of the time, and in all of your homework assignments, I'm going to ask you for the fraction. and it's the number of ways an event can happen over the total number of outcomes. So usually what you're looking for over how many total. The next one is a chance experiment or a trial. It's a controlled operation that yields a set of results. So rolling a die is an experiment you can set up, flipping a coin, picking marbles from a bag. It's an experiment that you set up to test things out. Now, an event is a specific a specific or desired subset from your experiment. So whereas rolling a die is your experiment, getting a 6 is your event. Flipping a coin is the experiment. Getting heads is the event. Your sample space is a list of all the possible outcomes of an experiment. Keep in mind that for sample space, like in the do now, you want to include the squiggly brackets. A complement of an event is the probability an event does not happen. So the probability of not getting 5 when rolling a die, if you're trying to figure out the probability of getting an even number when rolling a die, the complement is the probability of not getting an even number when rolling a die. So you always know it's complement when you see the word not. Equally likely means all outcomes have the same probability, so you are equally likely to get any number 1 through 6 when you roll a die. They all have the same probability. Or like a coin is a 50-50 chance. Certainty means the probability of the event is 100% likely to happen, or it's just equal to 1. You are certain it will appear. Impossibility is that the probability of the event is 0. In other words, it will never happen for sure. Now, let's talk about Venn diagrams. They are not as easy as some people think. So, if you're talking about the probability of event A happening, event A is everywhere inside the circle of A. So I'm going to go to the circle of A, and I'm going to shade it all in. You don't have to shade 100% of it. You can just draw lines to show this is where the shading is. Event B happening is you go to the circle of B and you shade everything in. Now, A and B means that you have to be in the circle of A and the circle of B at the same time. So if you were looking at A and then you are looking at B, these circles overlap in the center, right? So that's where your probability is for A and B at the same time, only at their intersection. Now, or is different because here is A, or you can have B. I don't care if they're both happening at the same time. As long as one is happening, you're good. So, or is everything inside of both circles, not just the overlap. If you want A and not B, if I were you, I would put a circle around B. You do not want to go in that circle. Now I'm going to look at A and fill in the rest of A. But I'm careful not to touch the circle of B at all. Same thing for, actually no, not same thing. Now we have neither A nor B. So that means you're not touching either of these circles. You don't want to go inside of them. So your only option is to go outside of them. So neither is everything on the outside. Let's talk about and probability. Now, they don't have to say the probability of A and B. They can just give you the symbol. And the symbol is called intersection. It kind of looks like an upside down U. The way I remember it is that it actually forms, if you put a line through it, an A for and. Now, and probability is also called the intersection, right? Because it's where the two circles overlap and have the same shared space. So we're talking about rolling a die, and they want to know the probability of getting an odd number and a number that is less than 3. So let's actually write out our sample space first. We have 1, 2, 3, 4, 5, and 6. The probability of getting an odd number. The odd numbers are 1, 3, and 5. Now you have the probability of getting a number less than 3. So we have 1 and 2 are both less than 3, right? In order to find and, you want to find the numbers that go in both of them. So both sets have one number in common, which means your probability is one option, the number 1, out of 6 different outcomes. So if you were to draw that out visually on a Venn diagram, you would have the numbers that can happen in A are getting an odd number, so A is odd. We have 3, 5, and remember 1 happens in both of them, so that goes in the middle. Then on the outside for B, your options are 2, because 2 is less than the number 3. Your options on the outside of both of them would be 4 and 6. And probability is the intersection, and there's only one number in the intersection. So you can either create a Venn diagram to think about it, or you can do it like I did over here, which I personally think is a bit easier. Now, trying this example, we have at a high school, some students play soccer, some play basketball, some play both sports, and some play neither sport. This scenario can be represented by a Venn diagram, which they gave you, and they want to know what is the probability that a randomly selected student plays both soccer and basketball. Anytime you see this word, circle it, just keep in mind that you're finding and probability. And means intersection or overlap or the upside down U symbol. So we're talking about the overlap, which is 21 students out of your total. So now you need to figure out how many total students are there. All of these numbers add up to be the total. So our total is 442 plus 21 plus 31 plus 339, which in the calculator would give you 833 students. Please be careful. This 339 is not the total. That's actually the amount of students that play neither sport. So your probability is 21 over the total number of 833 students. Now let's talk about or probability, which is called the union because you are joining both of them together. So this one's kind of simple. It's a U for union. You just have to remember that it represents OR. So let's look at the first example. You're rolling a die and they want to know what is the probability of getting a 5 or an even number. So your event A is getting a 5, right? There's only one option when you roll a die with the numbers 1, 2, 3, 4, 5, and 6. Only 5 is 5. Event B, getting an even number, you have the options of 2, 4, and 6. So together, remember, OR means union. Only one of them has to happen, not both at the same time. So in total, you have 4 different options, right? 1 in A, 3 in B, out of your 6 different outcomes. Let's look at that as a Venn diagram. You have A, B. In A, you have the number 5. In B, you have 2, 4, 6. You have nothing in common. There is no overlap. And then the other numbers would be on the outside. The 1, 3, and that's it. You actually have another option for this Venn diagram. Usually the circles are connected because you have something in common. However, when you don't have a overlap, your circles can be disjoint. That means they are disconnected. So you can have the 1 and the 3 on the outside, the 5 in circle A, and the 2, 4, and 6 in circle B. That's different than example 2, so let's look at that. Now we're rolling a die, but we're looking at a 5 or an odd number. Our sample space is still the same, 1 through 6. So event A is still only 5. But for event B, getting an odd number, the odd numbers are 1, 5, and oops, I left out 3. So 1, 3, and 5. And if you notice, this one's different than the other one because this one has an overlap of 5. So there's not 4 different possibilities. There's only 3 possibilities if you look at it, right? 3 different unique possibilities. The 1, the 3, and the 5. You're not going to count the 5 twice. So your real probability is 3 out of 6. Let's look at this one in the Venn diagram. Two, 4, and 6 never even showed up in what we were looking at in either event. Event B had 1 and 3, and the 5, because it was in both event A and event B, you're going to put it in the middle where both happening at once. So I think this one happens to be easier to see on a Venn diagram, that there's only 1, 2, 3 different events happening for the OR probability in this case. So keep in mind that when you're talking about OR probability, you have to add up both events, right? But you have to account for the overlap. So this brings us to our union formula, which is the probability of A plus the probability of B. That just means what's the probability of getting the first one, what's the probability of getting the other one, minus the probability of A and B. Remember, that symbol stands for your overlap, or the and, or the intersection. So you do have to remember this formula. It is not on your reference sheet. And just keep in mind that every time you have OR probability, we are subtracting the overlap. So let's look at another example. In this one, we have the senior class at Central High School. Some students prefer coffee, some prefer tea, some prefer both, and some prefer neither. So the data for the beverage preference for the seniors is shown in the Venn diagram below. They want you to find the probability that a randomly selected student prefers coffee or tea. Remember, OR probability is everywhere in the circle. So everywhere in the circle would be 60 plus 80 plus 40. And that's going to give you a total of 180 for coffee or tea. Keep in mind, you do not have to subtract anything because in this case, you only counted the overlap once for 80. You counted 60 once, you counted 80 once, you counted 40 once. You're not counting the overlap twice, so there's no subtraction. That's why it's easier to do OR probability with Venn diagrams. You just add up what you see. Now you actually have to find the total. To get the total, add up every single number that you see. So you have 60 plus 80 plus 40 plus 20. That's going to give you a total of 200 people. So your probability is 180 over 200. Let's try some mixed practice. So a bag contains 8 green marbles, 5 white marbles, and 2 red marbles. They want you to find the probability that a red or white marble was chosen. So if you want to actually try and get used to this formula, we have to first find the total number of marbles. We have that there are 8 green, 5 white, and 2 red. That is a total of 15 marbles. So going back to it, your probability of getting a red marble is there are 2 out of the 15, plus your probability of getting a white marble, which is 5 out of 15. And technically, you would have to subtract the overlap, the probability of getting red and white. You can't get one marble that is red and white at the same time. They all have their own distinct colors in this case. So that's just going to be 0 because it's not going to happen. You end up with a probability of 7 over 15. You probably didn't need the formula for this one, but as problems do get harder, you will need to use it. For the next one, we're talking about Venn diagrams. So before you do anything, make sure that you actually find the total going on. And the total is adding up all of the numbers, including the 985 on the outside. That's going to give you a total of 1,600. So in the first one, we're talking about the probability that a student is in Algebra 2. So you're going to circle the Algebra 2 circle, and that is going to be 210 plus the 85 in the middle, which gives you 295 people out of the 1,600. For part B, you're talking about a sophomore and in Algebra 2. So that means your intersection, your overlap between both of them. And that's going to be 85 out of 1600. Next one, you're talking about not a sophomore. So draw the circle, and remember, you want everything outside of it, the circle. So these 210 aren't sophomores. These 985 people aren't sophomores. So 210 plus 985 is going to give you 1,195 over 1,600 people. And the last one we're talking about, or probability, that's going to be everything inside the circles. So 210 plus 85 plus 320 gives me 615 people out of the 1,600. If you're talking about the probability that it will rain on Thursday is 5/6, and you want to find the probability that it will not rain on Thursday, this is your complement. So if there's 5 chances that it will happen, that means there is 1 chance that it will not happen, because starting from the number 1 minus the 5/6 that you already have leaves you with 1/6 left over. Remember that the probability plus its complement has to sum to 1. For number 4, they want you to find the probability of drawing a vowel. First of all, there are 1, 2, 3, 4, 5, 6, 7 total. There are 1, 2, 3 vowels. So that's just going to be 3 out of 7. Now you're talking about striped and a vowel at the same time. So this one is striped and a vowel, and this one is striped and a vowel. That's 2 out of 7 options. Now, striped or a vowel, this one is a vowel, this one is striped, 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 and vowel. B is not striped, nor is it a vowel. Striped, striped, and vowel. So that's going to be your 6 out of 7 total. If you're talking about a 6-sided number cube, which is a fancy way of saying a die, has faces with the number 1 through 6 on it, what's the probability that a number less than 3 or an odd number will be rolled? So let's say that we have A and B. For A, the numbers less than 3 are 1 and 2. For B, the numbers that are less than, I lied, the numbers that are odd, you have 1, 3, and 5. So the probability of your first event happening is 2 out of the 6 outcomes of rolling a die. The probability of the second event happening, the B, is 3 out of 6 outcomes. However, they have 1 outcome in common, so you're going to subtract 1 out of 6. That's going to leave you with a probability of 4 out of 6, right? Your 1, 2, 3, 4 different unique possibilities. And what's the probability of a number that is less than 5 and even? So we're looking for the intersection between them both, the overlap. So let's say this is A, this is B. A number less than 5 would be 1, 2, 3, 4. An even number would be 2, 4, 6. Their overlap is two numbers, right? The number 2 and the number 4. So that's 2 out of the 6 different outcomes. And finally, just some practice on probability. Pause the video and take some time to even read the question. So we're talking about soccer and basketball, right? A wants you to find the probability of just soccer. So circle soccer and fill it all in. B wants you to find the probability of not playing soccer. So what you're going to do is take the soccer circle and shade everywhere else. Terrible shading on my part, but you get the point. The probability of soccer and basketball, remember that can be the upside down U, the intersection or the overlap is in the middle. And the probability of soccer or basketball, the union of both of them, that should look like a U, is going to be everywhere inside both of the circles. Pause the video and take some time to read this question. So here we're talking about fiction books and ebooks. For part A, you only want ebooks. So you're going to go to E and shade in everything. For part B, we're talking about fiction or ebooks. So or means you shade in everything within the circles. F, E, and the overlap. For C, we're talking about works of fiction that are not available as ebooks. So you want to talk about fiction, but you don't want their overlap because the overlap is also ebooks, which you don't want. And D, neither works of fiction nor available as ebooks. So you don't want either of the circles. I would circle them, we'll outline them, and then make sure you fill in everything outside of those circles. So with probability, a few things to take away from this video is the difference between and or. So and probability is your overlap, also called the intersection, and it's going to look like probability of A and B, right? The little upside down U. Or probability is both of them, everything combined. It's called your union. And when you have it, it's going to look like probability of A union B. There is a special formula for this. So the probability of A union B, and keep in mind you don't want to write it as a U with a little tail. That's the letter U. This still looks like a U, but there's no tail like you have here. So the probability for or, the formula, is going to be the probability of one plus the probability of the other happening minus that overlap of the probability of A and B. You definitely want to make sure after this video you can remember the symbols and that you remember this formula since it's not given to you on the regions. And that's all for this video.